Thank you everyone for coming. Our aim today is to give you some context behind the intent of policy, as well as strategies for disaster recovery in the cloud. So my name is Bill Olson. I'm a principal security leader at AWS within our worldwide public sector solutions architecture team for Latin America, Canada, and Caribbean. So long title, but solutions architects, they partner with our customers as well as sales and AWS technical teams to craft solutions to help our customers' challenging mission. And as a security leader, I get to help both our customers and our internal teams with those security challenges. So today, I'm fortunate to be joined by Scott Lavigne. Scott, you want to introduce yourself and get us going?
Yeah, I'm Scott Lavigne. I'm the Director of Cloud Oversight and Core Technology within the Office of the Chief Information Officer at Treasury Board Secretariat. Business continuity, I think, is a topic that's very much related to disaster recovery, and who could have imagined when we all last got together years ago that we were months away from a global pandemic. And that global pandemic really tested our business continuity plans. For many of us, our lives changed. We became remote workers. Others who had to work on site faced new risks. Many of our children became virtual learners. And at a time when Canadians needed their government the most, the public service responded with new services. Some of those services were new contact centers to support benefits delivery. We saw departments collaborate together on data sets to inform policy decisions. We saw new mobile apps to support vaccine status collection as well as notification, and new collaboration tools to support remote working. And most of that was delivered with cloud technology and the internet. And that makes sense because we needed technology that was resilient, that could respond, and that could scale quite quickly. In my role, I'm responsible for information technology, policy, and strategy. I've spent a lot of time, and I work with other policy areas such as cybersecurity, information management, and privacy. Over the last few years, I've been very focused on cloud technology. And a lot of my work isn't actually about creating new policy for cloud, but instead it's working with departments and agencies to challenge a status quo bias. So what do I mean by a status quo bias? Well, if you think about the way we've delivered information technology in the government of Canada the last 40 years, we've bought base components. We've bought hardware, we've bought software, we've bought facilities, and we've engineered that together into a solution that we've tailored. We security assess it ourselves, we deploy it and operate it ourselves. That's our status quo. And we tend to have a bias to view that model as the lowest risk possible. And so when a new model comes along like cloud, we tend to view how it's different, the fact that we are now reliant on a commercial provider, our span of control is reduced. We tend to view that with a higher degree of risk, but often ignoring that our current environment, in fact, has risks within it itself. And if you think about the pandemic, and what it did was removed status quo as an option. Many times our current IT environment could not respond to the needs that the pandemic put in front of us, and so we had to go to cloud. So that brings me to the first of the three goals I have for the topic today. One of the things I want to do is challenge our status quo bias and do a bit of myth busting. So before I begin, can I just get a quick show of hands? How many people here are with the Government of Canada? Okay, great. I get a little jargony sometimes, so hopefully that enough people understand. And how many people here are directly involved with the delivery of systems, applications? So you're a developer, a solution architect, maybe a security specialist? Okay, great, thank you. If you spent any time on the topic of business continuity planning, you've probably seen a graph like this. And quite simply what it's telling us is the trade-off between the cost of keeping an incident short and the cost of an incident actually occurring. So looking at the graph, the vertical is the cost. And looking at the horizontal, we're looking at the length of an outage. The orange line represents the cost to try to avoid that interruption, right? And what it's telling us is the shorter the interruption, the more costly it is. And of course, we can't get to 100% availability. It just grows exponentially, those costs. On the other hand, if you look at the pink line or magenta, you actually see the cost that's occurred when an incident happens. And quite simply, the longer the incident, the more costly that outage is. But we have to achieve a balance. We can't spend infinite amount of money to get 100% availability, and there has to be a business-driven decision in there. In private sector, that's somewhat simplified, right? If you run an e-commerce website, you know what your loss of revenue is when your system is down for an hour, and you can say, is it worth the investment to avoid that hour of outage? In the public sector, we're much more challenged. We're driven more by reputational concerns. So we're concerned with the public trust. And in the digital era, the stakes are high. A public-facing site or service that goes out for 5 minutes, people start talking about it on Twitter. When a service goes down for 5 hours, it tends to make the evening news. And when a service goes down for 5 days, chances are your deputy minister or minister is answering questions in front of a parliamentary committee. So the stakes are high, but we need a balanced trade-off. Before I go on, a bit of a story, a personal story. When I was creating these slides, my 8-year-old daughter walks by and she says, "Oh, look, Daddy, you're drawing pictures." So she thinks my job is to draw pictures. And she's like, "I love the colors. They remind me of popsicle flavors." And then she says, "You should add a unicorn." So this brings me to my second goal today, which is I want to include as many unicorns as possible in my slides. Now, I have a confession to make. I have a weird hobby. I like to go on buyandsell.gc.ca, which is where we publish our procurement, and I like reading requests for proposals. We put very interesting requirements out there for industry to meet. And oftentimes, I come across examples like you see at the top, where we spec out a solution for industry. So we actually tell industry exactly how we want the solution to look. But that can be a bit problematic, especially in cloud, because cloud is a very commoditized service. The service that we consume is the same one that the CBC or the Bank of Canada consumes. It's very difficult to tailor that solution to us. The second issue we run into is time goes on, and how we solve a problem may evolve. There's new innovation, et cetera. Putting technical requirements like this in our request for proposals ties our suppliers' hands and says that they can't evolve over time. What we'd rather see is what we see in the second example here is more of an outcomes-based approach. We're focused on the outcome that we're trying to achieve, allowing the supplier to bring innovation. And in fact, when I go into this a little bit further, I'll even show how policy requires that we state our requirements as availability outcomes. So we can't take distance as an indicator of availability. It is an important input. In the case of cloud, we're leaving that up to the provider to do that work. But we can get our availability outcomes with the mechanisms that are available to us. The other thing I often see is people who are new to cloud, and they often come in with the mindset that cloud provider equals data center. And when cloud provider goes down, my system goes down. And so people will start to build architectures where they span their applications either across cloud and data center or multiple clouds in an attempt to give high availability. But clouds are actually composed of a cellular architecture that builds on each other. Each of those cells have an isolated blast radius. When a cell fails, other cells remain working. So what do I mean by that? Well, in terms of infrastructure, at the base level, we're talking about virtual machines, redundant use of virtual machines. When we move up the stack, we start to look at availability zones, right? Individual locations. And then at the highest of that is our regions. And Bill's going to talk a lot more about those things. But really, those are the mechanisms that the cloud provider provides to us to build highly available systems and systems that can fail over. Each of those components, VMs, availability zones, regions, et cetera, have their own SLA attached to them. And we, again, focusing on those availability outcomes. We use that to build our solutions. The other thing I often see is we have multiple providers available. They often use common terminology, but it doesn't mean that those things like VMs and availability zones all hold the same SLAs across providers. I've seen examples where what requires multiple regions in one cloud provider can be accomplished with one region in another cloud provider. So we have to be focused on the SLAs that are there. Okay, so this gets me now into my third goal for today, and I need your help with that. We often work with our colleagues at AWS. They like to abbreviate availability zone as AZ. And that's problematic for me because it doesn't use the Queen's English. So I'm asking all of you, when you work with your colleagues at AWS and they start talking about AZs, correct them with the proper Canadian terminology. It's called an AZ. So that's why I ask. So last thing I'll talk about before handing Bill and get into the exciting stuff is we said we were going to talk about data residency. Why are we talking about data residency when it comes to disaster recovery? And simply the reason is in a disaster recovery situation, we often want to fail over to another location. And sometimes, well, I'd say quite often, I get asked by departments, can I use services outside of Canada? Maybe you want to fail over to a location outside of Canada. Maybe simply the service isn't available in Canada. And in 2017, when we originally published our data residency policy, we had a very binary view. We said certain sensitivities, certain categorizations of data could not be stored outside of Canada. In 2019, we updated our policy, and we made it a risk decision. We show a preference for Canada in certain security categorizations, but we leave the risk decision to be made by a departmental CIO. The thinking behind that is you know your business best, and you know the implications of those decisions. We've also published guidelines. You can find them, a guideline on service and digital, section 4.4. We have a write-up in there around some of the different criteria that departmental CIOs should consider when making that risk decision. So that's a bit of myth busting. I'll hand it over to Bill to get into probably why you're really here, which is the technical stuff.
Thanks, Scott. Appreciate it. So Scott obviously knows he's focused on policy. I'm focused on security. So why are we talking about resiliency? Well, for me, resiliency and security are very tightly coupled. You're going to hear the word choice quite a few times in this session, whether it's related to strategic, architectural process, or other decisions. Choices you made are going to dictate how well your organization can recover from an adverse event. And understanding these choices and the trade-offs can not only help you identify the right balance for your organization, but also help keep a bad day from becoming a really bad day. And those choices are not going to be a one-time event. So resiliency is not pass-fail. It's something to work on continuously. Identify the potential failures so you can mitigate them, and identify the fastest way to perform recovery. And so with that in mind, I want to start with a few fundamentals. A number of the options that we're going to get through in the session today are going to assume an understanding of these. And the first one is understanding the shared responsibility model. So in this model, AWS takes care of the security of the cloud, and you as a customer take care of security in the cloud. So of the cloud includes the physical infrastructure, the facilities, the actual compute, the building blocks. And a car analogy is often the easiest way I find to relay this model. So if you can think of AWS as a bit like driving a car, you don't have to know how the engine works or how the air conditioning keeps you cool. You just need the skill to drive the car and control the basic functions of the vehicle. And so if you decide to leave the car in a busy area with the doors open overnight, you're not really holding up your end of the responsibility. And so your responsibility as a customer is going to be based on the cloud services that you choose, which in turn is going to determine the amount of configuration you need to do to create a secure and resilient workload. And it's also important to point out that that shared responsibility model, it's not static. You as an organization have some choice about where that line falls. So AWS offers technologies that run code, can manage data, integrate applications, all without managing servers. So serverless technologies feature automatic scaling, built-in high availability, pay-as-you-use billing, all to increase your agility and optimize cost. And these technologies eliminate some of that infrastructure management tasks like capacity provisioning or patching, so that you can focus on writing code for your application and your customers. And so as you move to the cloud, you have to consider that element of choice. What is your organization good at, or what are you not good at? Or even what's taking up so much time, it'd be nice to shift that to AWS. All right, second fundamental, Scott's already touched on this a bit, is it's important to understand AWS region design and the terminology we use. So AWS has a concept of a region, which is a physical location around in the world. So in Canada, we've got a region outside of Montreal. And we call each group of logical data centers an availability zone. So Scott's noted that we should call it AZ. I'm based in Toronto, but learned my ABCs in the United States, so I'm going to stick with AZ. All apologies. So each AWS region consists of multiple isolated and physically separate availability zones. So an availability zone itself is one or more discrete data center with redundant power, connectivity, and networking. So for our Canada region, that's 3 availability zones, each consisting of one or more discrete data centers. Plus, we do have a second region coming to Canada. And that second region is going to be out by Calgary. And it's a big announcement because over the next 15 years, AWS is going to invest in the neighborhood of $21 billion into the regional infrastructure, which will have a knock-on effect of increasing Canada's GDP of roughly $39 billion over the same time frame. And that Calgary region is currently on track to launch in the fourth quarter of 2023. Most importantly, it'll be a full region. 3 new availability zones, which will be suitable for production workloads. It's well suited for applications that service the western part of Canada. So you'll effectively have 2 primary regions, Canada West and Canada East. I'm actually not sure which direction I'm pointing, but one of each. Also, the Calgary region was specifically designed to draw from clean energy. So from a carbon footprint standpoint, all workloads in Canada are going to benefit. And sticking with that infrastructure design, our experience shows us that for high availability applications, there's a Goldilocks zone for infrastructure planning. It's a distance that's not too far, not too close, it's just right. And that Goldilocks zone is the distance between availability zones and data centers that can support aggressive resiliency requirements while keeping latency low enough for high availability applications. Because at some point, the limitations imposed by the speed of light make data replication with relational databases or running distributed systems very challenging. And so when you look at the risk natural disasters pose, it's definitely the farther away, the better. But after only tens of kilometers, there's diminishing returns. Beyond tens of kilometers, the types of disasters you're mitigating will likely be extinction level events, like the meteor that killed the dinosaurs. Final fundamental, I just wanted to highlight AWS supports more security standards and compliance certifications than any other offering. This helps our customers satisfy compliance requirements for virtually any regulatory agency around the globe. And for Canada, that includes an assessment by the Canadian Centre for Cybersecurity. So AWS's completion of that training and assessment, it builds on our deep commitment to provide protected cloud environments for the Government of Canada. And now circling back to the topic at hand, resiliency, I wanted to start with some high-level benefits for leveraging the cloud with disaster recovery. So with traditional DR, there's a large upfront investment and expected hardware needed, as well as the amount of time involved in provisioning, configuring, hardening, installing, testing that hardware, as well as the overall management of that infrastructure. So a few key benefits of the cloud are removing that upfront investment, reduced overhead IT management, and the ability to have systems up in minutes. So as we delve into different resiliency strategies, you'll see that some can become very complex. So having that flexibility to test different scenarios without that upfront commitment in both cost and time can be transformative for a lot of organizations. And I mentioned earlier that choices are not a one-time event. So being able to course correct or otherwise modify your strategy or the tools you're using is a big benefit of DR in the cloud, and it can allow you to flex with your business mission. So clearly, this all starts with the requirements. Which applications or workloads need to be protected, how a disruption would impact your business, defining the corresponding RPOs and RTOs, which I'm going to touch on in a minute, as well as taking into any compliance considerations. So the core of your requirements are effectively how much data can you afford to lose and how much time can you be down? And those answers to those are typically known as the recovery point objective and the recovery time objective. The recovery point objective, RPO, that's a maximum acceptable amount of time since the last point of data recovery. So that determines what's considered an acceptable loss of data. Recovery time objective, the RTO, that's a maximum amount of delay between the interruption of service and restoration of service. So that determines the amount of time that's acceptable to have the service down. So it's important to be clear about what the implications as you work through the RPOs and RTOs. And we're going to get into some of those trade-offs. But first, we want to start with what policy tells you.
Yeah, so I work in a policy shop, so I had to have a policy slide in here. And so when we look at business continuity in the Government of Canada, we're really looking at the mandatory procedures around business continuity planning. So what do those mandatory procedures tell us? Well, they tell us a few things. The first one is to define, everyone needs business continuity management and procedures. Pretty simple. It also tells us to perform a business impact assessment. So what's key about this is we're making those availability requirements. We're starting with the business. What does the business service require? And that's an injury assessment. So injury can be along the lines of physical, financial, reputational, psychological, et cetera. It also says that to define our business, our availability requirements as outcomes. So maximum allowable out time, RTO, RPOs. Remember in the beginning when I talked about stating outcomes versus speccing the solution? Policy tells us to use an outcomes-based approach. It also tells us there's an ecosystem. We're very focused on the technology implications, but business continuity is a people, process, and technology problem that needs to be solved. So you have to look at the entire ecosystem. Can your administrators access the system? Can your users access the system? What are the networks they use? What about if you have to push a change into production in order to get your system back up? Is your repository there? Is your code pipeline available? It also tells us we have to look at our contractors and suppliers. That's AWS, right? And so we have to be aware of their SLAs and what our agreements are with them. It also tells us to assign a security categorization that is commensurate with the degree of injury. So there's that term injury again. So why do we link security with disaster recovery? Well, there's a number of reasons. The first is both the business impact assessment and the security categorization deal with injury. Both are an injury assessment. The next is security incidents can result in a loss of availability. So these are incidents that we have to be aware of. And then also as well, those security control profiles that we use, those hundreds of security controls, have a lot of controls that help us maintain a resilient system and a system that can recover. So looking at the diagram, putting it all together, if you start on this side of the diagram, you'll look at those services, right? And so I have some examples in here. Don't look at it too closely. There are mistakes in here in terms of some of the numbers, so don't look at it too closely. But again, starting with the business, right? That business impact assessment. What do the business owners need? What can their business tolerate? What is the impact of that? And from that, determining their maximum allowable downtime. Then you have to map your businesses to the systems that support those businesses. And it's often many systems support one business, and one business requires many different systems. So there's a crosswalk that needs to occur there. So as we get to the center of this diagram, this is where we as IT professionals really come in, right? And we can walk our business owners through some of the options, and we're going to get into that in a little bit, that go through, and what are the implications of those availability outcomes. And then as we get to the other side, we of course see the security overlay, the security control profiles and the security controls that are implemented. Bill?
So as you're considering your requirements and your desired outcomes for the related policy, so it's important to not only focus on resiliency, but to understand what that means. So resiliency encompasses both availability and disaster recovery. So disaster recovery focuses on disaster events, where availability focuses on more common disruptions at a smaller scale, like component failures, network issues, load spikes. So objective of disaster recovery is business continuity, whereas availability is maximizing the amount of time your application is doing its intended function. So keeping in mind what Scott noted earlier, it's important to consider the regular day-to-day availability, uptime, and SLAs of your cloud service provider. And we're going to touch more on availability in a moment, but I wanted to stick with understanding your requirements. So that understanding your requirements also includes what type of failures are you planning for and how those can be categorized into varying degrees of likelihood and impact. So how are you mitigating against these failure scenarios and whether you're focusing on the more probable or rare categories? So thinking back to that Goldilocks slide, for context, are you spending your time planning for extinction level events or the things that are more likely to impact your organization? So let's talk about a few common strategies. The guidance your policy provides you, how your organization answers those RPO, RTO questions, the type of failures you're going to be planning for. These are all going to help guide you toward a strategy. Complexity and cost are also going to be influencing factors. And as I describe these, I'm going to use the term location. Because the strategies, you can use any of these with a single AWS region, leveraging multiple availability zones, or you can use multiple AWS regions. So going left to right, starting with backup and restore, that's a suitable approach for mitigating against data loss and corruption, or providing some redundancy if you're only deployed to one location. Beyond that data loss or corruption, you're going to have to consider how to spin up your infrastructure to run the configuration application code. The pilot light example, that includes, sorry, I lost my notes. I am going to go back. Oh, thank you. Pilot light approach, you can replicate your data from one location to another, provision the core workload of your infrastructure. So the resources that support that data replication and backup, those will always be on. The other elements like your application servers, databases, object storage, those are going to be configured but turned off. And they'll only turn them on in the event of a disaster recovery or for testing. So unlike the backup and restore approach, your core infrastructure is always going to be available. And you can have the option to quickly spin that up and scale it out in the event of an issue. So warm standby, that ensures there's a scaled down but fully functional copy of your production environment in a second location or more than one location. So the approach extends that pilot light concept by decreasing the amount of time to recovery because your workload's always going to be on. The approach also allows you to more easily test and implement continuous testing to increase your confidence in your ability to recover. And the most complex down the far end is the hot standby. So in this strategy, you can have a multi-site active-active or a hot standby active-passive approach. With the multi-site active-active, all your traffic will be served to all your workloads wherever they're located. With the hot standby active-passive, the traffic will be served to a primary region, with the others only be used in event of a disaster recovery. And so that multi-site active-active approach, that's the most complex and costly approach to disaster recovery, but it can reduce your recovery time to near zero with the correct technology choices and implementation. So clearly architecting your workloads to achieve your resiliency targets, it's going to be a balancing act. So the graphic on this slide helps illustrate some of the trade-offs. You've got some of the common strategies along the top and other considerations down the side, like design complexity, cost to implement, operational effort to secure, and even environmental impact. And Scott, I know you really like this graphic, so do you want to give us your thoughts?
I really do. And it's from an AWS blog on disaster recovery. If you just Google AWS blog disaster recovery, it'll come up. But part of the reason I love this is because we as architects love optionality. And we love being able to sit with our business owners and explain the implications of different options. And so as Bill already said, across the top, we see different architectural patterns. And so Bill walked through that spectrum just a slide ago. And then down the side, we see the different considerations and the trade-offs. So it really summarizes a lot of information and provides us as solution architects great tools to be able to describe what the implications to our business owners of making one choice or another. But I also think there's a dimension that's missing on this table, and that's time. Because what's interesting is, we look at when I talked earlier about our status quo, our traditional IT environment, and we compare that to cloud, there are some unique qualities around cloud that differentiate it. One being that there's low upfront capital cost with cloud. Okay, so we don't have to buy a lot of kit, we're paying as we go. The second is low lead times, right? The time to provision new resources in the cloud is quite short compared to our traditional IT environment. And that allows us to do things that are quite difficult to do in a traditional IT environment. For example, start on a pattern 2 and move to a pattern 3 or 4. So maybe our availability requirements change with time. If you think about a traditional IT environment, often moving from one pattern to another means having to start a whole new project with whole new investment. Cloud provides us certain agility to be able to move forward. Bill, turning over.
Yeah, sure. So we're talking about availability. So to put some context around what that means, availability is typically expressed in the number of nines. So 99.9% availability would be somewhere in the order of less than 9 hours of downtime a year. So on average, like 2 minutes a day of downtime. Add another 9, 99.99%, you're down to about under an hour of downtime a year. And 5 nines, 99.999%, that you're down to about 5 minutes of downtime a year. So clearly, each 9 added to availability, it costs your organization an order of magnitude more. So for a customer-facing service to be 5 nines available, all the supporting services need to be even more available, to Scott's point of the crosswalk and the weakest link. So I've seen it put into context where if adding a 9 is equivalent to adding a 0 to your total cost of ownership, like all the infrastructure spend and people, is it going to be worth it? So that P5 pattern on the far side, that might make sense for something like a core banking application that has zero tolerance for regional disruption, or RTO of real time and RPO of near zero data loss. But even so, that pattern, as Scott's alluded to, takes a high level of process maturity. So we often recommend customers start with something less complex and work their way up. And so Scott, I've got a few questions here. So I'm going to cheat and use my notes. Are there any evaluation criteria that you think the Government of Canada teams would be particularly interested in?
I think there's a few of them. And the first one that jumps out to me is cost to implement. You remember that first graph I showed where it showed an exponential relationship in terms of costs, in terms of the the higher availability you want, the costs grow exponentially. But if you look at the cost criteria here, it really shows how cloud can change that curve, right? You don't see a large differentiator as you go across the row, at least not to the degree of other criteria such as design complexity and operational effort. And going back to that optionality discussion, when you sit with a business owner and they say, well, I want seconds of downtime a year or minutes, you have these type of tools where you can say, well, what if you could occur a few hours of downtime a year, and then back off to a pattern 4, giving you easier operational effort and lower design complexity. So again, this is an interesting tool you can use when discussing the implications of different availability outcomes with your business owners. The last criteria I'll look at, and I find this one interesting, is environmental impact, right? As a society, we're becoming more and more aware of the implications of digital services on the planet. And while we don't talk a lot about this today, we are talking a lot more about it. Certainly in the government, we have a focus on greening IT. So I think this is a criteria that's very useful to include in here, and I think we'll get a lot more conversation going forward.
Awesome. Another question. So when I work with my Government of Canada clients, they often mention mission critical services. So how does that translate into these patterns? So
when we look at the definition of a mission critical service, it really talks about a high degree of injury. And thinking back to that slide I had before with the business impact assessment, it really means going back to the business owners and saying, is the loss of your service or the interruption of your service going to incur a high degree of injury? So our definition doesn't have a set maximal allowable downtime or RPO or RTO. So really, a mission critical service and the systems that support it could map to any pattern here. It's really about working with the business again, explaining those trade-offs and understanding their outcomes.
Awesome. And you also started off talking about how with cloud, you can advance from one pattern to another. Can you think of cases where this might apply to the government?
Yeah, I think, we see cases where availability requirements change over time. And one that strikes me and is simply, we use a very waterfall approach today where we go from requirements to design to build to deliver. And what can happen is down that waterfall, we discover that we missed information or simply we didn't state our availability requirements properly. And so we have to react and change maybe the architecture, right? But again, because of cloud's pay-as-you-go model and the quick provisioning around it, we're able to make that change without starting a whole new project. Another example is, applications are very integrated today, right? And so all it takes is for one application to have a low availability to impact a whole chain of availability. So we might discover an application whose availability needs to be re-architected over time. And the last example I can think of is often business continuity plans are the target of auditors. And so through an audit, it's discovered that certain systems don't have the availability that's required. And so a management action plan is required. And so we have to be able to re-architect the availability of our systems. Again, when I talked in the beginning about our status quo bias and how we look at our traditional IT environment, often being able to change the availability and changing our disaster recovery strategy around our applications requires a whole new project. But with cloud, because of the low lead times, because of the low upfront capital, we can often make that change much more quickly. And that translates to agility. And thinking about in the beginning when I used the example of the pandemic wasn't a single event. It was years long and is still happening. But the pandemic years ago and the pandemic today look very different. And what the government of Canada has had to do during that time is constantly pivot and constantly react to how the pandemic has evolved. And that agility, that ability to quickly change over time, provides us options that we can give to our business owners, and that's really valuable.
Awesome, thank you. I think your examples help highlight and align with some of the high-level benefits of cloud we touched on earlier, that agility to allow you to pivot and flex with your business mission. Okay, so we didn't have a whole lot of time in our session, but I wanted to squeeze in a quick example. So top right of that slide, you can see there's a relatively simple architecture for an application that includes some load balancing, auto-scaling, some storage, some compute, and a database. And so it's kind of following somewhere between that P1, P2 pattern on that earlier slide. And it's leveraging a single region, a multi-AZ disaster recovery strategy within that single region. And the design suitable so that it can withstand DR events like outages, flooding, localized disruption. And so in this example, which would be cooler if it was like animated, in the event there's an impairment with an availability zone, the primary one, health checks would start failing for those EC2 instances. And that load balancer would be able to shift the traffic from the impaired availability zone to one of the others that were in working order. And we also have to emphasize testing. So I'm focused on security, so I've got a plea to develop an incident response plan up here. But generally with disaster recovery, you have one of two types of plans, a disaster recovery plan or a business continuity plan. A security incident response plan would typically be an element or an event within a disaster recovery plan. But I wanted to reemphasize that resiliency is something to work on continuously, to identify the potential failures so you can mitigate them, identify the fastest way of doing recovery, and you cannot do that if you're not testing. Put another way, it's rare that somebody can just run a marathon on a whim. It takes some practice and discipline to run one properly, and same with disaster recovery. Regardless of the strategy you land on, it takes some discipline and practice to react properly. Practice your plan. How do you navigate from playbook to playbook? Which teams are involved? How do they communicate? These are all the stumbling blocks that keep an issue from being resolved in an expeditious manner. And how you test is important as well. So disaster recovery is not a simple exercise. So tabletops, paper exercises, those are a great start, but they're risky. There's some additional options out there like the AWS Well Architected, which it's a framework to allow you to compare your workloads against best practice for architecture and design. There's services like Security Hub that can continually assess your workload against best practices, and there's also open source offerings out there that can help you identify potential risks. And taking the idea of testing a step further, there's chaos engineering, which is an approach that introduces failures in order to find the weak spots that would be difficult to find in any other way. So for context, traditional testing like unit testing, functional tests, these would still be required, but that type of testing doesn't address the complexity of a production environment. Running a traditional test often only verifies a known condition. So chaos engineering lets you compare what you think will happen to what actually happens in your system. So you basically break things on purpose. And that teaches you how to build more resilient systems. So you can think of it as a preventative control to avoid larger compounding issues down the road. And there's a quote from a blog post by the Netflix team about their experience running their video streaming service on AWS. And the quote is, the best way to avoid failure is to fail constantly. And they had two principles they learned from the process of moving their infrastructure to the cloud. And the first was no system should ever have a single point of failure. And that single point of failure would be one error or failure would result in hundreds of hours of downtime. The second is never be 100% sure that number one's true. Your teams have to have a method of testing to continuously assess and validate that number one is not true. And so So the service, the fault injection simulator, that is designed to help you perform a controlled experiment on your workloads by injecting and letting your teams see what happens, and you learn how to avoid those failures. So it's designed to be easy to get started with. All you need to allow you to test your system against some real-world failures, whether those are complex or simple. And it's also integrated with our Amazon CloudWatch alarms so that you can put some guardrails in place in the event the test goes in an unexpected direction. So the goal of chaos engineering and the service itself is to help improve the resilience and performance, uncover your hidden issues, as well as uncover blind spots, whether that's in your monitoring, your alarming, or your general observability. And with that, Scott, why don't you start with a recap of what we discussed today?
Yeah, so availability and residency decisions really start with the business, right? And we talked about the business impact assessment, and we talked about the departmental CIO's decision-making around residency. So those are really, again, we as IT professionals work with the business to understand their needs. State our requirements as objectives, right? And we talked about some of the terminology around that. Availability, maximum allowable downtime, RTO, RPOs. Try to avoid speccing out solutions. And then going back to the theme of optionality, right? Understand what the options are that's out there. Again, we explained some of the different patterns that are available and what the implications are. So working with your business owner to understand what the implications are of their availability outcomes.
And just a reminder, customers are responsible for the availability of their applications. So it's important you define what a disaster is and have a disaster recovery plan that reflects that definition and the impact it may have on your business. So ensure you have that plan and validate that plan with some testing. With a disaster recovery plan that hasn't been tested, it's unlikely to meet your resiliency objectives. Before we sign off, just want to point out we do have additional resources for topics we covered today, one of which is the AWS Resilience Hub. And it's a place to define, validate, and track the resilience of your applications on AWS. We also have resources to support your compliance, security, as well as skills development. And with that, thank you all for attending, and a big thanks for Scott for sharing the stage and his wisdom.
Thank you.